We're going to start with the simple aldol condensation, where we react two molecules of aldehyde or ketone together. And for this one, we're going to use two molecules of propanol in the presence of base and water. And these two will react under these conditions and give us the following product. This step here is really just the aldol reaction, because we haven't lost a small molecule yet. And the product is a beta hydroxy aldehyde. Now you'll notice we've used equilibrium arrows here to say that there is an equilibrium between starting material and product. But then what happens is a subsequent step in the presence of the base, we lose water. And you can think about this proton at the alpha carbon and the OH at the beta carbon being lost. And when we lose water across that bond, we end up with the products. And the product here, now we have a double bond between the alpha and beta carbons. So this is an alpha beta unsaturated aldehyde. And because the second step is where we lose the small molecule, that's kind of the condensation portion. So the easiest way to see exactly what's going on here is to look at the mechanism. And there's a few steps involved, and we'll break these down. So the first step is to make the enolate. So do that with one of your carbonyl compounds. So we have two molecules we're starting with, so we're going to use one of those to make the enolate. So we have this. Here's our base. And these protons at the alpha position are relatively acidic. So in the presence of the base, we can deprotonate at that position. And that will give us this enolate, and you can draw both resonance structures. But it's this resonance structure we're going to use for the subsequent reaction. The second step of this mechanism is nucleophilic addition of the enolate to the second carbonyl. So now we're going to take our enolate and I'm going to rotate that carbon group down, and I think you'll see why when we draw the product. It just makes things come together a little more easily. And I'll draw our second enolate in blue so we can keep, or I'm sorry, our second aldehyde in blue so we can keep track of it. So now we have a nucleophile with a negative charge, an electrophile in the carbonyl. So this nucleophilic enolate attacks the carbonyl carbon like this. I'll draw our new bond here in red. And now we've added those two carbonyls together. From here, you'll notice that your reaction conditions have acid and water in them, so we can just use water to protonate this oxygen. Right, and I'll keep this hydrogen, I'm going to leave it out and make it implied. So here is where we get our beta hydroxy aldehyde structure that we drew up at the top. And these steps here are in equilibrium. So now we need to do the condensation step to get to the final unsaturated product. The third part of this mechanism is the condensation step, or the loss of water step. And the way that works, we will take our beta hydroxy aldehyde, this I don't think we really need to color code anything. We still have the base around. And remember that our net result, if I draw in the hydrogen here, is that we're losing this hydrogen and this OH. So the way that this works is the base, just like we did in the very first step, the base will deprotonate that alpha proton and form an enolate structure. So now we have that negative charge, but in this case, we have this nearby leaving group, the OH, and this negative charge can come over here to form the pi bond, and then you lose the OH. So the net result is, I should have put the water formed in this step. So in the first step, you get rid of the hydrogen. The second step, you get rid of the hydroxide, but the net result is we've lost the H and the OH from this molecule. The driving force for this final step here is the fact that we formed this conjugated system. Ketones can work just as well as aldehydes in this reaction. So here's a case where we have two molecules of cyclohexanone. And we're not going to go through the entire mechanism for this, but the way you can think through this if you're trying to predict the product, draw the enolate of one of the ketones. I'll do the enolate where the negative charge is on the carbon. Redraw the second ketone. That will be your electrophilic ketone. So we have our nucleophile, our electrophile. Now we'll draw the arrows on this step just to kind of show where the bonding is occurring. So after this, and in the presence of water, we form the bond. Here's our new bond in red. That's going to attach to this carbon. So I'll just draw the six-membered ring. Here's the attachment point. And then when that attacks, we get O minus, which then becomes OH. And then in the presence of the base, remember that we lose H and OH across that alpha beta bond. So there's the final aldol condensation product. In this case, the product is an alpha beta unsaturated ketone.